strange. All right. Wait, what? Wait, what's the... I'm sorry, what is the... Whoop. Alright. Now we should be good. Apparently, it's a very low resolution. I don't know if it is or not. Oh god, it is. I'm looking at it on my phone. That is... I'm gonna... Yeah, I know. Okay, hold on. Why are you like this? Why are you... Settings. Output. Okay, yeah. Video. Holy crap. That's so bad. Why is this like this? Hold on. Okay, that's a bit better. I know that's a bit better than... It's not 240p. Why, god, that was so bad. Well, it's still 240p, never mind. Hold on. Okay, it's a bit better. It's not as good, is basically what's happening. Let me... Oh, you can hear it. I can't... Stop. Stop playing. Stop. So... hopefully, if you're watching the VOD, I don't know. I gotta really... Also, I'm gonna have background noise because people are here. I bet I can actually get it to a higher... Okay, let me try that. Maybe it's better. I don't know. Okay. I think it's just going to be as good as we're going to get it. Okay. So guys, what is up? Yes, it is me. I was about to say, I don't have good internet, and I will not have good internet for a while. So whatever you get is the highest. Yeah. So yeah, I'm back. I guess I'm just doing a bit of a stream right now. Why not? I'm working on a little project right here. Hopefully it'll turn out to be a video. and if it doesn't, oh well, it can get better. So also tell me if there's any issues. There probably is, because like I said, I have terrible internet, but whatever. I'm going to webcam, what the heck, manage, no, cancel. YouTube Studio is a bit weird. This is all new. This is definitely all new. I don't care what's... Okay, so it's good now.
What are you doing?
Of course, someone walks in. I told you to have people coming in. Well, anyways, so yeah, hopefully the project I'm doing right now turns out to be a video. And if it doesn't, oh well. So what I'm going to do is I'm going to have my phone play the video, and then yeah, audio, it's advanced, not turn up the quality on my side. So, okay guys, welcome. Like I said, God, I don't know how to stream. Anyways, so this project is going to be a scantron app, to where I can plug in a piece of paper and then it automatically grades it. And so we're at the start of the project now, and I figured I might as well stream some of it so I can get some video, just in case I want to do anything. I didn't record the first part of it, basically the setup. Good news now, I'm not using Eclipse anymore. I'm using IntelliJ, which I feel like people would be very happy about. I'm gonna hide this one, so I'm gonna pop out the chat and then minimize this so I don't see that crap, because it looks awful on my side, but I know it's not that awful because I can see it on a not my computer side, basically. So yeah. So anyways, like I said, hopefully this turns out to be a project. You can still use Eclipse. It's not that bad of a IDE. It's just that I know IntelliJ has way more like support for all the things I want to do. It's basically like IntelliJ is the newer version, and even then, if you really want to, you can still use like VS Code, because it doesn't matter which IDE you use. I just chose to use this because I know it's better in some ways, and the ways that I want to use it. So anyways, yeah, at this point in the project, I think all I got is to where I can take an input image and then make it low res in grayscale. You also got a Gaussian thing, basically to blur the picture, so we can do edge detection, which is what this function will do. So let me run that real quick to show you what I mean. I already have it. It's right here. These are the two pictures. That's, hold on. Here's what, okay, so result is equal to yeah, that's what I do for simpler projects, because it's a lot easier. So that should work, and so now if I run it again, here we go. So, and then it does its thing, and then let me open it up. See, it's finished, and so here's what I plugged in. So it's just a piece of paper. This is my desktop, by the way. I plugged in a piece of paper that just says hello there, and so this is what I want to basically. It will not be. I don't think it'll be using an AI. I think I can get around that, because I could have used OpenCV, or Open Computer Vision, which it automatically figures it out, and it's really easy. It's only probably less than 50 lines of code to make this entire project. But I figured it's a good educational experience to do this all myself, because then I can learn about convolutions, object detection, and all that. I don't think it's going to use an AI, though. I feel like the mic might sound bad. I think I'm using the wrong mic. Let me check. File, settings, audio. Is that? Okay, that's the right one. Okay, maybe just because of the bitrate and how it's super low, and that I made the video super high, so I can't. It may be my side. Okay, maybe. Okay, it's not. I don't know. Anyways, so let me show you what the output image is. Oh, not that res output. And so basically, it's just a blurry. It's just like a blurry, low res image version of this. It's quiet. I think I can up that live right now. Okay, so yeah, and then it goes from here to here, and that's all I've gotten in the code. If I can pull that back up, minimize that. All right. I don't care about layers. Put you over here. Yeah. Problem solved. There we go. So anyways, I really do want this up though, because it has like statistics, but then I see this, which doesn't look that good. I see my side of the video, which means and since I'm the one who's streaming it, my internet's being taken up by that, so whatever. Anyways, yeah, okay. So we're here at the edge detection part. Which means that I have to go to the Wikipedia page of Sobel edge detection, the Sobel operator, as it is called, and it's not that difficult. It's very similar to the Gaussian blur. Get that back up. So it's basically a convolution to where it's two convolutions, one for the x and one for the y, and then we can estimate the gradient, or estimate the derivatives, because it's calculus. It's always math. It's always freaking math. And so with the magnitude, it will give us basically a pretty good edge. And as you can see, let me actually go to the canny edge detection, which is what I'm trying to get to. It's like a step process. So I got the Gaussian filter. That's done. And then I'm on the second step of finding the intensity gradient, and then there's a whole bunch of ways you can do that. And And I'm going to use the sawbell because it's pretty simple. So, it should give us two images if I go down here. Yeah, so here's the X gradient, here's the Y, and then if you put them together, it should give us edges. So let me put that in there. It's I don't have to do something super complicated like having to make my own filter. I just probably plug it in. I could probably hard code it in. So 9. I'm just going to use a 1D array for this. And what was it? I was about to say, I think the problem with if you're going to get to the bit rate, well, hold on, I can probably up the bit rate a bit. I'm going to have to stop the stream again, but whatever. What about now? Okay. I have no idea how that's gonna work. It was only noticeable on the wiki page. Yeah, it's probably because I was moving that around. So I don't know how well this will do. It's dropping a lot of frames, which I don't think is that good. Hopefully this one is going to work. Okay, I don't want it that high. I know what the problem is, like, because there's other people on the internet right now, so that's taken up a lot of the bandwidth, and also I just don't have that good of an internet to begin with. So I think the good news is recording is really simple. Recording would be really simple. So yeah. Anyways, if I can, let me check what you guys see. Advanced. And then if I scroll a lot, let me see what that looks like, because that's where the bitrate's gonna frickin' panic. Oh god, okay, so just don't scroll a lot. Oh my god. God, man. Whenever, okay, I know in a couple months this will get fixed because I won't have the internet issue, because that's the bottleneck at this point is the internet, because I don't have good internet even to begin with, and with other people already on it, I can't do much. So anyways, back to this. I'm gonna put this over here so I can see it, because I'm gonna have to refer back to it. So 1, 2, 1. Wait, no, I'm doing this the wrong way. 1, 0, and then -1, and then 2, 0, -2, and then 1, 0, -1. Okay. God, I can't even. -1. I'm using a number pad for this, which isn't that good. And then yeah, hey Spider Tyler, I am alive. So yeah, why isn't this working? Why is there issues here? What are you complaining about? Oh, because I don't need 9. I just need. Yeah. So that's that, and it's literally the same as this, except not as intense. So result.get width and get height, so it goes through the entire image. We don't need. Do we need grayscale? What do we need? I'm trying to think how this would. I think I'll just have it as a gradient. Gradient. I keep forgetting to have the chat up. Okay, and so radius. It won't be radius. It'll just be. See, because the radius of this is 1, so I'll put that. I'll probably just put int subble radius, and then sample x, sample y. If it's out of the bounds, don't even bother with it. And then okay, yeah. So get this is fine. And then here we go. So gradient plus equals that. So the value, which is this, and then the filter with the Sobel radius. And then the thing is, so I'm not for sure I want to put it in an image just yet. I kind of want to see. Well, this will be what it is. Yeah. So how do I normalize it? So how do I normalize the? Only 8 points. Yeah. Yep. This is a weird MATLAB implementation. I don't know why. So how do we normalize this? Because I kind of want to see where you. I want to see this picture. I want to see this picture right here. Let the bit rate recover, and then this picture right here. So. I see that. So normalized. I could just Control F. Normalized. So there's only 3, and they're all there. That doesn't help me. Okay, technical details. Okay, I don't care if they're separable. I just want to know. Because if I do it like this, if I just straight up put the gradient in there, it may not be. They may not be RGB values. They won't be RGB values. I can tell you that. So how do I normalize it? Okay. Let me just run that and see what happens. So example.jpg might take a little bit longer because I'm going through even more convolutional networks. Okay, so here's what, let's see what the output's gonna be. Close this one out and put this one. It's not the same. It's the same because I didn't edit it. Yeah. So the results. I really need to have this like up here so I could see it. Result is equal to sub-L detection result. And by the way, guys, hopefully this turns out to be a video, and I'm recording it at higher quality on my side of it, as in it's actually fine. So yeah, hopefully it's fine. I could check real quickly because I have stopped the recording before. So files, raw videos. Let's watch this one because that last one doesn't even look like a video file. Looks like something went wrong with it. Wait. I have no idea how that's gonna work. Oh God, no. That's not good. So it's recording at the same bitrate. Give me a minute. I'm just gonna see if I can. Here we go. Here we go. Okay, there we go. So I can stop the recording, and I can go to output. Do I have to stop the stream too? I think I have to stop the stream. Okay, hopefully that's better. God, man, I haven't streamed in a while, so I have no idea, and also bad internet, so that doesn't really help me anyways. So yeah, so let me run this again, because now I actually put the edge detection in there. Okay, yep. That's what I thought. That's what I thought. So the gradient isn't what it is supposed to be. The problem is I have no idea how to normalize it. So what it looks like it does, what this looks like it does is this, it has a threshold. It finds the max. Okay. So what this does is it's either black or white. So if it's above the threshold, if the gradient's above the threshold, it's black. If it's below the threshold, it's white. But the thing is, I have to do both of them to find it. So I can just add it to, I can do this again. And for this one, we do, this one is the horizontal? This is the vertical one. Vertical. And then horizontal. Horizontal. Go back to the Wikipedia page for moi. Look at the horizontal one. There we go. So 1, 2, 1, 0, 0, and then -1, -2, -1. Okay, so now I can do the vertical one first. So radius, vertical. Wait, I can do it in one for loop, can't I? I can do it in one for loop, yeah. So this is the gradient x, and then this is gradient y. This is probably yeah, it's saying that it wants it to do horizontal. Yeah. Replace all two. Location. I don't know. Index. That's a good one. Okay. So why are you complaining? Oh, it's because I don't have a gradient. Why? Shoot. No. Nah. Redo. Okay. And I forgot to pull you back up. Gradient y. There we go. So, and more issues. Okay. So, after all that, now I can do the formula to find the gradient. And let me actually have that threshold value up here. So int threshold, and they put 70, but we can change it because it's a threshold. Yeah. So here's what we do. So now that we have both the gradients, we can say not let, that's JavaScript. Double final. God, let me type. Gradient is equal to math.square root math.pow gradient x to the second power plus math.pow gradient y to the second power. And so now we have the final gradient, and then we can do if final gradient is greater than threshold. Let me do color. Final color is equal to new color, and then white. And so is it like this? I can just do color.white. And then if it's greater than the threshold, or if it's less than the threshold, I can do color.black. Final color is equal to color.black. It's supposed to be less than the threshold. Wait, no, it's supposed to be greater. And it's supposed to be the other way, because if the and then finally, after all that, we can say final color.getRGB. So now, what this should do is this should give us all the edges it's detects, or at least it shows the gradient. So now, if I run it and I put in the example, we should have something else or an error. And I'm hoping for the something else. Okay, so no error, which is good. So now let me drag it into my thing. Ah, it's perfectly white, except for the edges. So I think there's an issue. So apparently, so what if I put the threshold down to 1? And right now, because I'm tired of writing example, I'm just going to put it in the code itself, because right now I'm not really looking for efficiency or it being able to do any image right now. Just I want it to work on the specific image that I need. Yes. So, okay, you're finished. So now if I do output, open the image. Okay, it's still white. So the threshold's way too high, or way too low. I need it to be. I don't even know what the gradients are like. 200. Well, the thing is, so like, if I go back here, where are you? Where are you? Where's the? Here we go. So like, it's supposed to be white. Okay. Sure, higher threshold. Let's try it. If all else fails, I can just search up a tutorial, but I really don't want to do that. I didn't do it for the Gaussian filter. So, yeah. Okay, so it's done. Let me pull it out. Open. Okay. That's slightly different. It's like it's that. So, what does a higher threshold mean? Run it again. I see it has a little line right there. So it's doing something. I can tell you that. Whoa. Wait a minute. Wait a minute. Look at that. I don't know how well this is done, but it is. Let me overlay it with the original image. So here's the original. Okay, I need my layers back. So if I do that, and I scale it up to this, and then make it slightly hold on, let me paste it down, and then make it some transparent. Well, it's definitely detected that there's paper there, and it's detected there's a bend right here. And see, it's worked here, but then it's also gotten the rest of this. So like, it's detected this as one big edge, which is not what I want. So I wish there's a way to edit the threshold live, but right now it literally is just outputting images. So yeah. Okay. So output. Can you go back? There we go. Open the image. Okay, so yeah, it's back to corner. I don't think I'm doing something right. I think I'm doing at least a little bit right, but I don't know if I'm doing it completely right. So operator job. Maybe I'm doing something wrong. So okay, well this is OpenCV, which is I do not care. I don't care. Oh, what the heck? Ew. This person doesn't even bother with arrays. Hold on, let me show you the Stack Overflow. Just straight up did like just straight up added like all that, didn't even bother, which I mean, what, cool, I guess. So let me see. So there are two issues first. Okay, well okay, so I got the grayscale. And it's supposed to give us this image. In fact, that's a pretty good idea. Stack Overflow gave me some good ideas. So it's basically, it's used this image, and so I think I'm going to do that as well. Just so I can see where I'm going wrong. So Java, workspace. Oh, that's what the project's called. I forgot to mention that. Example 2, and it's PNG. Oh, is that, hold on, let me actually refactor that. Actually, it doesn't really matter. I mean, I could just example2.png. So I know it's not going to work if I do it. See if I do this, output would be something different. And let me just, so output, let me see what you are. Open. Yeah, it's all white. Well, it's also really small. I don't think I need to scale this one down. It's really small. Let me just not scale it, which means I have to do a bit of retyping. So there we go. Excuse me. See, that went really fast. Okay, so let me exit out of this output. Let me put the output back in there. I mean, I don't think it's, as I would say, I don't think it's changed anything. It's still white. So, yeah. Anyways, let me go back to Wikipedia. And let me see. Okay, yeah, this one apparently it works. This is what I want. This is what it, because like even I'm not even doing that complicated of a thing. I'm literally just trying to set it. So yeah. So engine.png opens up it gets the that, and then edge colors. So it gets the max gradient, and then it sets it, and then the scale, and then it sets it. Okay, so that's how I do a scaled value. Okay, I don't get. What? Wait, what? They're doing a different thing for grayscale. That is strange. I was about to say this is what I did for grayscale, and this one's completely different. What? Where? Okay, well here's that. I don't actually, I don't really care about bad grayscale. I'm just going to. So what this is what they're doing. So they're, okay, that's right. And then max. So we need to find the max gradient, and we need to scale it accordingly. So going back to here. Where are you? No, these are all, here we go. So edge detection. In fact, what happens if I don't do this? If I just plug it in raw. I feel like it wouldn't do that much, but I'm just gonna see. It's not really raw. I still did the grayscale, but whatever. So so here's the gradient x, here's the gradient y, and that's what I'm doing. That's what I'm doing. That's that. I'm basically just doing this in a for loop, and then max gradient. And then to output the image, which is what I want, at least for now, for testing. Okay, so I don't think okay, let me get rid of this. And then here's what we're gonna do. So we're not gonna set it just yet. We're just gonna do the final gradient. In fact, I'm just going to call this the final gradient by just casting it to an int. And then instead of threshold, we're gonna put this on a new line called max gradient, and a negative integer dot, or not even negative, it's just integer dot min value, because I love that. I love using absolute mins and maxes when doing this. So we're going to say max gradient is equal to math.max final gradient and max gradient. And then after we have done that, we actually do, okay, we need to store it in a 2D array because we need to do that. So the result, in fact, we don't even need this until afterward, after this for loop. We just need a 2D array. You know what, I'm going to make it a double because of the values. So double array edge value, or gradients, is equal to new double array, and then image dot get width, no, get height, and then get width, image dot get width. And then with this, now we can say max gradient, and then gradients of yx is equal to final gradient. And then after that, we go through it once again. And result does not exist just yet. We have to do image. So after we get to the max gradient, this is where result comes in. Crap. There. No. What? Any, no errors. Okay, so now, result, and then we don't need gradient. In fact, we don't need any of this. We can just, and so now we need double scale is equal to 255.0 divided by max gradient. So now we have the scale, and now we can just say color, final color is equal to results. Oh wait, not result. It's equal to new color. Wait, we haven't done it yet. Hold on. What did that Stack Overflow page say? It's the scale, and then edge color is just the times the scale, and then it's equal to that. So what we do is we do gradients by x times scale, and so double grayscale is equal to that, and then we have to cast it to an int. So why don't I just cast it to an int here? Int. There we go. That might actually cause some. I think I messed up with that. Anyway, I think, did I mess up with that somewhere? I don't think I did actually. So grayscale, grayscale, grayscale. In fact, I don't even need this. I could just say results.getImage.set RGB at the x and y, and then the color, so new color grayscale. Oh wait, I already had this copied, and then dot get RGB. So now after all that should give us a picture with all the edges, and using image 2 we should get it. So let me open this up. Okay, it's done. Okay, well, here's what we got. I don't think we did something right, because this is literally just the grayscale image. Okay, so grayscale image result.getImage.set RGB. Okay. So I don't think that's supposed to be what's happening. Because like I'm doing all this, I'm just doing it to where it's not it's not this, it's spread out. Well, I'm just coding, yeah. Well, this is hopefully supposed to be for a project. Also, don't mind the low quality. I have crappy internet. So math. So yeah, I'm doing all of this. I'm doing all this, and then scale, and then it goes through it again, grabs the edge color. Then it does the grayscale, and then it goes and it outputs an image, which is what I'm doing that. Where'd you go? But this is weird, because like here's the gradients, and I'm calculating the gradients here. I think I'm, wait, no, that's right. So yeah, that's GX, so that's correct. Wait, that's my OBS, never mind. This is weird, why aren't you working? So we got the max. Yeah, okay, that just creates that. The weird thing is it's literally just the grayscale. Like if I were to not do this, let me see what it outputs. If I literally just go straight to grayscale. And this is saved. So here's the grayscale. And here's the final. It's just a little blurry. I mean, the edges do the weird funky thing, but like other than that, there's no difference minus the blurriness. Unless I did something wrong up here, which I don't think I did. So let me turn back the edge detection. That is really weird. Another thing I can do is I can literally just copy and paste this. I could literally just copy and paste. See, I can do this. The thing is, like, I don't know why his is working and mine is not. So if I copy and paste, it obviously changed where I need to change. So get grayscale, I need to grab that as well. Apparently it's a better function because I didn't know grayscale was so reliant on green, which is a weird, but whatever. So now, okay, so image dot get image dot get RGB, which is correct. So let me just bum 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 bum. So it takes all that, it does the math, it gets the math gradient, and then what I want to do is I want to get a result out of this. So boom, and then the result dot get image dot set RGB, and then using, yeah, I don't know, it's because it's weird. I don't know why I don't know why it's so reliant on green for the grayscale. It has mostly green, some red, and then B. Cause like here's how I calculated it when I go up to my grayscale image. I just calculated it by adding it all up and dividing it by 3, and it looks fine. But like apparently, this is a better way, which I'm not for sure why. Well, anyways, so now that I've literally just copied and pasted the code, let me see what the output would be for this. Okay, what the heck? So this one has found the edges. So there's something that this code is doing that I'm not. So is it because I'm not? Is it because of the grayscale? So if I just copied and pasted that and instead use this function, get grayscale, if that's the case. I don't think that's the problem. That'd be a really weird, specific thing. So, like, I was about to say, I do all this already. So, grayscale is equal to get grayscale of this. And then I don't need any of that anymore. So now if I go back to here and I do my implementation, does it change anything? I don't think it will. I just think I may be overlooking something. So I'm just going to exit out these two. Yeah, so yeah, this is just the normal this is a normal grayscale image. This is what we're aiming for, and this is what we're getting. It's basically not changing anything, which I don't know why it wouldn't. So gradients. So if I go back to here, this is the weird thing. Get width, get height, and then I don't know where this is coming from. I have Control F though, so yeah, this is literally, it's just a useless, it's not used at all. So I don't know why you would use that to begin with. So it gets the width and the height, it goes through it. I do a loop, and maybe there's something wrong with my loop, but it worked for the blur, so I'm not for sure. Radius is 1, and then it goes from 1 to 3, 1 to 3, and that's J, and that's I. And then it gets the sample. If it's out of it, it doesn't do anything. And then it grabs it, and then gets the red, which it's the same thing, because you can get any of them, because it's grayscale, all of them are the same. And then gets the index, and then it should, for the X, it grabs whatever it is, and it should be right. So you say, like, that's strange. And I'm doing the math, the final gradient, and math square root, and they just did it the long-winded way. And then max gradient, if the max gradient's less than g, it sets it that, which I'm doing here. Max gradient is equal to that, and then it finally puts it in the 2D array, which I'm doing right there. I don't know what I'm doing wrong. Is it something wrong with this? So here's what I can check. Here's the good news, is since it's technically in 2 parts, I can paste this and edge colors. Oh, I need to enable. Ah, crap. This is. I'll do gradients. But then it's J, I, because I flipped it on mine. And why are you complaining? Oh, that's a double. Wait a minute. I don't think I meant to do that. Where are you? Final gradient. Yeah, that's not meant to be a double. That's supposed to be an int. I don't know why I did that. That's strange. Well, anyways, so it should grab the edge color. It should grab it and set it. And then I want it to return the result. So, if I run this, error, cannot find X. Oh, this is image.getWidth, and then this is image.getHeight. So it's finished. So now if I put this into here, okay, so it's the grayscale. So it's something wrong with this. So I'm just gonna get rid of you. So it's something wrong with this part. So somewhere it's not. Okay, so if it goes through the radius. Yeah, God. If it just tells you there's an error and like nothing about it, I don't think I would use it. I think I would just be like, well, I'm done coding. And that's my career right there, if I couldn't. Yeah, I was about to say, like, it's just saying, well, you wrote this program wrong. I think you should redo it. 'Cause it's just one big or just red error. Maybe it's something wrong with this. Maybe it is. Maybe I should do image.getWidth, image.getHeight. Okay, then is there something wrong with this? No, I don't think so. And then the radius is 1. And then that is a change. If that would definitely be noticeable if that was an error, because negative 2 billion color doesn't exist. I have, okay, so it goes to the height, it goes to the width, and then it goes through and gets them all. So it goes from -1 to +1, -1 to +1. And then if it's outside the image, it doesn't bother with it. It basically treats it as black, which it could be a problem, but it's not that bad of a problem, especially since most of the images edges you shouldn't really detect an edge on the edge of the picture. And then value index. So value, it gets the gray, since it's already been grayscaled, and it's already grayscaled up here, and I fixed it to where it's grayscaled the same way. See, it gets them all. -1, and then adds them, which is what I'm doing. And then it calculates the gradient value. See, I don't understand what I'm doing wrong. Maybe something's wrong here. Like, so here's what I can do. I can comment this out, and I can do this. And then plug it in there. It's going to be commented out too, so. And then these are all X, 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 X. So and then y, why aren't you working? And so that gets all of them, and then that's gradient x, that's gradient y, and then the final gradient is that. And is there any difference between that and that? Math of square root, no. So if this works, then we have our culprit narrowed down. No. It's because x and y. I have to change this to y and 1 and then -1, -1. So try that. Where? 210, 210. So down here. What? Oh, it's because now it's that allow you to group projects like workspaces, or like, I don't know what you mean, like group projects. It allows for like multiple people editing at a time, because it told me that immediately as soon as I downloaded it. But like you can have workspaces as well, like if you just run now I got a text message. So now it should run. Okay. So now if we go here and we exit out that, and then we put this in here. Okay, it's still at the grayscale. So now nothing's working. So here's what I'll do. I'll just take this, get rid of it, and then take all this and paste it, and then uncomment it, and then so now if I run this, it should detect the edges. Okay, perfect. And then if I close this out, it should be this image basically again. Yeah, it's this. Okay, so this works somehow. In a subfolder in the project view, so you don't have to search every project I have. Yeah, it should work. It does that. See, like here. If I probably can do it. I don't have multiple projects in my workspace. Like all I have in my workspace is this one, and I bet you can see it right here. So I don't know if it's like the I mean, I could just make a new project. See, this one doesn't exist anymore. New project. If I can, no library. Yeah, no. Okay, I don't want it to be in Java. I want it to be in this one. And then I don't want this. And then I don't know, example project, and then slash example project. If I were to do that better, I probably could have done that one. Yes, create. So now if I do this, I will see if it does what you want. So here's example project. Let's manage projects. I mean, that's that, but like, I don't think there's probably a plugin, but I don't know. At least it has the open recent. Yeah, this window. So. Anyways, so now that this works, I'm going to fix it because, God, this is awful. So first of all, note to X and Y. Anytime you see X and Y, just use image.getWidth. So image.getWidth. Yeah. I do not know. I'm not an advanced user. I just use it because I know it's better for my sanity in the long run. So max gradient is equal to integer dot min value. I'm just going to call this gradients. This is get width, so image dot get width, image dot get height, and so this, okay, so let me change this to gradients, and then this can become int, and then int, this is gradient, and so I don't need this anymore, and then I don't even have to do this. I can just say max gradient is equal to math.max gradient max gradient, and then gradients is equal to gradients. So this is a pretty simple one. Scale, result, gradients, and then yeah, dark theme doesn't come built in, which is stupid. I agree. You have to use dev style. I haven't even used a light theme in a while. I mean, obviously, like Stack Overflow. I mean, like subconsciously, you like chose to use the light theme. I can go to dark theme if I signed in, which I don't know why I'm not logged in, which is kind of weird, but whatever. Not doing that on stream. Okay, so all this is fine. Let me just, of course, changing a couple things, making sure it still stays the same. Finished. I don't want you anymore. Output. As would say, okay, so it's still the same. Edges are still there. So this is all fine. One thing I can actually change is we can say times scale, and then int. So now, and then instead of doing this complicated mess, we can just say that edge color is equal to, yeah, dark theme. I tried that for Chrome, but it's really buggy for me, so I don't really want to stick with it because, you know, it doesn't really work for me, at least the one I used, and I think every website's going the dark theme way, so I don't think it's going to be that much of a problem anymore. So now if I do new color dot get RGB, and then instead I could just call this edge color 3 times. So now it should simplify things once again, making sure nothing has changed. So yeah, nothing's changed, so everything is perfectly fine. And now the big thing that is going to be the changing value. I like say, yeah, I mean, I guess eyesight's better than no eyesight. So yeah, I guess we can change this. Well, I do want to change this to X because I, in this instance, really is not that helpful because like we're going through the image. Another thing I could do is I could just say Sobel radius, and this is exactly what I did before, but I'm just gonna start from a working example and go to the one I want. So now if I do, now I can use I and j for this one is equal to negative Sobel radius, and then I want it to go to positive, and then do that same for j. So j is equal to negative. I did it again. So Sobel radius j is less than or equal to that, and then j plus plus. Oh, that was not j, that's I, so j. So now, int value is equal to get grayscale of image dot get image dot get RGB of the x, so x plus I, j plus y plus j. So now that should get rid of having to need all of this. And so if I do something like int gx is equal to 0, gy is also equal to 0. Shoot, then okay. So now then gx is equal to plus equals value times, and then this is where we need this, so Sobel vertic. So I'm just going to solve that to keep it consistent. It's a new int array, and then for this, and we're going to have to pull up the Wikipedia page again, and then type it in. So 1 0 negative 1 2 0 negative 2, and then 1 0 negative 1. So there's that, and then I need the same but for the y. Sobel y is equal to new int, and then this one is 1 2 1 0 0 0 negative 1 2 negative 1. So there we go, and then Sobel x. And then this is the kicker, so we need to do j times, and then however long it is. So we'll actually be j plus Sobel radius, so we can get it to 0 through whatever it shall be, times however big it is, so radius times 2 plus 1, and then plus I, but again it has to be that, and so that should work there, and then times Sobel y. And it wants me to do it, so I guess I will. And maybe this is the problem. Maybe this was the entire issue, and if it is, then I can work on that. But at least we'll actually have like the culprit. So this is the x and this is the y. And I'm making sure. Okay, I'm going to also change this to x and y because consistency. And then bonk, 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 bonk. Okay, so now if anything happens, it's gonna be what we just did. It's gonna be this. So yeah, I know it's how many? It's 4 nested loops, but that's just because that's how convolution networks work. So if this doesn't do edge detection, we know what's the problem. Okay, it did it. So now we have a working solution with the code that I basically wrote last time. So yeah, I was about to say this is exactly what I wrote last time, but it didn't work. So yeah, strange. Cool. Thank you, Stack Overflow. You're always as useful. So now, the good news is we got step 2 done. I was just step 2, and we've been streaming for how long? I don't know how long we've been streaming, but now we need to do something called thresholding, which I know what thresholding means, but I don't know what it means in this context. So pulling that Wikipedia page back up again. Minimum cutoff suppression is an edge thinning technique. Okay, so I think we're getting rid. By the way, before I do anything, I'm going to put the original example back in just so I can see what that looks like, because I do not know what it looks like. It's running. Oh crap! It's running with. It's too big. So now if I have to go back up to here. So I'm going to do that. I want to scale the image. Okay, I'm going to have to do a solution. Let's go to new image data, image. So now I don't have to worry about commenting out things. So I don't know if I want to blur it. I'll see what it looks like without it blurred. Okay, I don't know what this error is down here, but I don't care. It's a bit bigger. I don't know how much bigger. I don't know how big the example 2 was. I can check. So if I go down here, I open this image. This is 250 by 188. So yeah, this at a scale of 4 would be like twice as big. So that'd be 4 times. It did it. So let's check the edges on this one. So what did it detect? Oh, that's nice. All right, yeah, that's actually really good. So it obviously detected my keyboard. Yeah, detected my mouse pad. And then it's the big one. It detected that there was a piece of paper here. There's the pen cap. There's a cord, pencil, Rubik's cube. Yeah. So obviously when we're going to do the final thing, we're not going to be doing it on my desk because detecting pieces of paper, this could be a piece of paper, this could be a piece of paper, this could be, because they're all rectangles. But we wanted to detect this piece of paper. And even then it really detected the text well. But as you can see, a lot of noises. Well, I don't know if you can see it. It doesn't look like you can see it on my screen, but trust me, there's a lot of noise. So actually, just to show this in action, does this work well? Let me check. So, by the way, we are going to have to make another function for the edge thinning. So that's what I'm just going to do real quick. So, private static image data. I think we're just going to call it edge thinning. And then image data. So result is equal to new image data. And there's a lot of optimization to be had here because obviously now we're going through 4 steps of going like doing the thing over and over and over again, which it's not that good. Yeah, see, it took, I don't know how long it took to do that, but it took way too long in my opinion. So we add that up here. Result is equal to edge thinning result. So there we go. So now we'll mess with that, but before we do that, let me see what the blurring does to the picture. It didn't do much. I mean, it made the text slightly different, but like it didn't change much. So I don't think I'm going to do that, because even then, like, all the noise is still there. I don't think it's a good thing to do, and it added a lot more, so I'm just not gonna do it. It was a really good exercise, but I guess I didn't need it. Well, anyways, going back to here. So compare the edge strength of the current pixel with the edge strength of the pixel in the positive and negative gradient direction. And the edge strength of the current pixel is the largest compared to other pixels in the mask with the same direction. Pointing in the wire will be preserved. Otherwise, the value would be suppressed. AKA, I'm assuming. There's another Wikipedia page. Edge thinning. Okay. Okay, so how do I do it? Well, that's math. Okay, so second order approaches. Choose a type of, so 8 connectivity. I don't know what 8 oh, so yeah, okay, we're all immediate, okay. Remove points from north, south, east, and west, and do this in multiple passes, i.e. after north, use the same semi-processed in other passes, and then remove a point if it has no neighbors in the north, it is not the end of the line, or is isolated, or if removing the points will not disconnect its neighbors, else keep the point. So we have this algorithm. So, and then remove it from the north, south, east, and west. So remove a point. And then well, do I have to do that here? Because I don't think that, like, obviously it's detected that this is an edge, and it's already 1 pixel as it is, so I don't really think I have to do that. One thing I do have to do is crop the image. So like here, I could just crop the image as it is. Don't need you. So make that bigger. It's about to say just shoot. Make that better. So now if I do it like that, and then save this as first mod, yes, Java, workspace, and then now put example.png. I guess I can get just example.png here. And then I don't need you anymore, don't save. And then I don't care about you. And then this is the output. And then this is the new example.png. So now if I go back to my code, I don't need you anymore. And then PNG. You're no longer there. Now you can delete, not that one, you can delete. So now, it should just, when the output is, it should just detect those one edge. To be completely honest with you, I don't think I even need edge thinning. I think I just need, I'm just going to get rid of that function. I don't really need it because, like, it's already thin enough, and it's not necessary for it to detect, for like an algorithm to detect a rectangle. And like I said, I don't even need the filter because it doesn't change much. So yeah, so let me check the output of this new one. So open. Yeah, look at that. So it's this pin mark down there has also got detected. It's pretty cool. The fold is slightly detected, not that bad though. So yeah, like look at this. All you need to do is you need to, for the final, like to get it right, we need to detect that, if I can get the brush, that this is a corner, this is a corner, this is a corner, and this is a corner. And of course I won't be using such a crappy piece of paper for the final thing, but like when we detect that these four corners exist, then we can do some perspective skewing, which is another thing I don't know how to do and that I will have to research. In fact, let me work on that now, with just a change of pace from image processing. So, and by the way, this is the image data class. It's not that much. It's literally just like such a, it also formatted it weirdly. How dare you? Okay, and I also don't need example 2 anymore because we know that edge detection works. So yeah, there we go. Edge detection finished. So now our next thing is to, I'm going to be doing some skewing. So let me just, I don't know what to call this. I don't think I want to call the image. I think I'm going to call this image processing, or like a package image processing, and then put the scantron refactor and then the image data in here, because like this is not even a scantron at this point. I'm just going to call this refactor image processing. So now with this image processing, because this is where literally everything is, so I'm just going to make this a new one. Skewing. Pull you back up. So now with this, what I want to do is I want to take, I want to be able to skew an image and then process it. So how do I do that? That's a good question. Let me move that. Let me move you over here so you guys don't have a nice saltage on your screen. So skewing rectangles with corners. Okay, I don't care about skewed. Yeah, here we go. What is the mathematics behind skewing a rectangle from Gravit.io? Okay. Perspective skew Java. Wait, what? This is already, apparently this is already in Java. It's in Java X Media, but it's probably, it's not even, it's literally not. No, I want to do the math myself. I don't want to. Okay, yeah, I don't care about. Okay, probably shouldn't add Java. I probably should just mathematics. Well, I just thought like we could easily do it through a matrix, but we don't have a well, we do, but like. Well, now that I think about it, we can literally just, since we're using a buffered image, in image data, we're using a buffered image, we could just turn that into graphics. So, in fact, we don't even need skewing. We just do this in the image data. Pull you back up. Okay, so see, like right here, so we're already doing something like that with the scale image, but like, so public void skew image. So like, well, the thing is like, so what will happen to the image? I'm trying to think about how we could do that. We probably shouldn't actually do that in image data. We probably should have like a shape to do this. What the heck? Okay, that was weird. Oh, well. Okay. That was weird. You know what, actually, it's getting pretty late. I think I'm going to call it a day. We got edge detection. That's pretty good. We got plenty of footage for the video. And yeah, I'll probably actually research on my own time. And yeah, I guess I'll see you guys